Hello and welcome. You know, machine learning can sound pretty intimidating, right? But what if I told you we could break down a really powerful algorithm using a simple story? No complex code, no heavy math. All you need to do is think about your own neighborhood. Ready? Let's dive in.
So, picture this. You just moved into a new place, and there is this one house, one neighbor that you haven't met yet. They're a total mystery. You're curious, you know? Are they going to be quiet, a big partier, a gardener? How would you even start to figure them out?
Well, you'd probably do what any of us would do. You just look around at the houses right next to theirs. Are their lawns perfect? Are there bikes and toys all over the yard? You start picking up clues from the people living closest to them.
It really just boils down to that old saying, you are the company you keep. We kind of just assume that people are a lot like those they live closest to. And that simple human instinct, that's the secret sauce to the entire algorithm we're about to unpack.
So let's break down what we're actually doing here, step by step. First, you've got your new house, the one you're curious about. We'll call that our query. Second, you have to decide how many of the closest neighbors you're going to check out. That number is K. Third, you see what the majority of those folks are like. And fourth, you make an educated guess. See? Simple.
And here it is, the big reveal. That whole common sense process you just mentally walk through, that is, believe it or not, the entire logic behind a super well-known and powerful machine learning algorithm. You just did it without writing a single line of code.
It's called K-nearest neighbor, or KNN for short, and our little story just perfectly explains the whole idea. It's what's called an instance-based method, which is a fancy way of saying it uses the original data points, our neighbors, to make a decision about a new unknown one. It just classifies the new guy based on a majority vote from its K closest friends.
Let's make this connection super clear. Our mysterious neighbor? In algorithm speak, that's the query data point. The idea of closeness on your street, that becomes a precise mathematical calculation called Euclidean distance. And that number of neighbors you decided to check on, well, that's our famous K. See, you were basically thinking like a data scientist the whole time. So how does a computer actually measure closeness? It's not a vibe or a feeling, it's a hard number. The algorithm literally calculates the straight line distance between two data points. Most of the time, it uses this formula you see here, the Euclidean distance formula, to figure out mathematically who the nearest neighbors really are.
Okay, that's enough theory for now. Let's actually see this thing in action with a real example. Imagine we have a chart with a bunch of data points, and we're about to drop a brand new one in. Our job? Figure out where it belongs.
All right, take a look at this. We've got a whole bunch of data points that are already labeled as either a plus or a minus. And then, bam, right in the middle, we have our new query point, XQ. It's our mystery neighbor. Just by looking at where it's sitting, what's your gut tell you? Is it a plus or is it a minus? Let's see what KNN thinks.
Now this is where it gets really cool, because the entire result hinges on our choice for K. If we set K to just 1, we only look at the single closest neighbor. And well, that one's a plus, so XQ gets classified as a plus. Simple enough. But what if we change our strategy and set K to 5? Now we have to draw a bigger circle to include the 5 closest neighbors. And if you count them up, we've got 3 minus symbols and only 2 plus symbols. The majority vote flips. And just like that, XQ is now classified as a minus. This shows you that choosing the right value for K is everything.
This brings us to a couple of key things you gotta know about KNN. It's famously called a lazy learning algorithm. And why lazy? Because it does basically nothing during the training phase. It just memorizes all the data. All the hard work, calculating distances, counting votes, that all happens at the last second, right when you ask it to classify a new point.
And like any tool, KNN has its pros and cons. On the plus side, it's pretty good with messy, noisy data because a few weird neighbors probably won't change the majority vote. But on the downside, because it's so lazy, it can be really slow when it's time to make a prediction. It has to compare the new point to every single other point. It can also get easily confused if you have tons of features, a problem data scientists call the curse of dimensionality.
So that leaves us with a pretty cool final thought. The K-nearest neighbor algorithm is so powerful because it's so simple and intuitive. It works on this one basic assumption, that similar things exist close to each other. So if an idea as simple as you are the company you keep can power a whole machine learning model, well, what does that say about all the hidden patterns and structures just waiting to be found in the data all around us?